Law of chemical equilibrium and equilibrium constant. Law of chemical equilibrium is the mathematical expression and can be obtained by applying law of mass action to a reversible reaction in equilibrium. That means we are going to derive an equation. We have to satisfy three conditions. One, we have to apply law of mass action. 2. It should be a reversible reaction. And 3. The reaction should be in equilibrium. Under these three conditions only we can derive the equilibrium constant. By listening to the audio, you try to derive the equation and see that whether you are getting the final answer. First one, consider a general reaction. This reaction is important. Without writing the equation, even if you derive the whole equation, you are not going to get any marks. Write the general reaction, the same, that is AA plus BB. It is a reversible arrow. This is a reversible arrow which is very important. If you put a single-headed arrow, even if your derivation is fully correct, you are not going to get any mark because it is meaningless. Unless it is a reversible reaction and it occurs in an equilibrium only, this is valued. Therefore, put an reversible arrow and CC plus DD are the product. In this, capital A, capital B, capital C, capital D are all reactants and products. Small a and small b, small c, small d are all stoichiometric factors of the reactants and the products. See, where A, B are the reactants, capital A, capital B are the reactant. Capital C, capital D are the products. Small a, small b are the stoichiometric factors of the reactants. Small c, small d are the stoichiometric factors of the products. According to the law of mass action, the rate of forward reaction, the meaning of forward reaction is that reactants react together and forms product that is from left to right. That is the starting. We are writing always the reactants on the left hand side. That left hand, the reactants when it is converted into product, that is called forward reaction. And in this forward reaction, in applying law of mass action, by listening to the statement or the definition, we know very well that rate of the forward reaction is directly proportional to concentration of A raised to the power small a, concentration of B raised to the power small b. And this reaction is a forward reaction, can also be written as using a constant. For the forward reaction, we consider K1 is the constant. Therefore, rate of forward reaction is equal to K1 into the product of the reactants raised to the power of its stoichiometric factors, that is concentration of A raised to the power A, concentration of B raised to the power b. Similarly, rate of backward reaction, that means backward reaction means the products will react together and gives the reactant. That means the right hand side will react and forms the products of the left hand side. That reaction is known as backward reaction or reverse reaction. In this case, the reactants are this, that means CC and DD. Therefore, applying law of mass action, the rate of backward reaction is directly proportional to concentration of C raised to the power small c, concentration of D raised to the power small d. Or if K2 represents the constant for a backward reaction, rate of backward reaction is also equal to K2 into concentration of C raised to the power C, concentration of D raised to the power D, where K1 and K2 are the rate constant. We call it as K1 and K2, the rate constants of the forward and backward reaction. At equilibrium, that is the third point, we applied law of mass action, and it is a reversible reaction. We put the reversible arrow. And the third point, at equilibrium, what happens? At equilibrium, the rate of the two opposing reaction becomes equal. Therefore, at equilibrium, the rate of forward reaction is equal to the rate of the backward reaction. Now we can substitute the values that we got for the forward reaction and the backward reaction. Forward reaction means K1, concentration of A raised to the power A, concentration of B raised to the power B, which is equal to K2 into concentration of C raised to the power C, concentration of D raised to the power D. Write that equation and equate it. After that, you find out what is K1 by K2. K1 by K2 is equal to concentration of C raised to the power C, concentration of D raised to the power D divided by concentration of A raised to the power A, concentration of B raised to the power B. At a particular temperature, K1 and K2 are constant. We are using K1 and K2 are constant. Therefore, K1 by K2 will be a constant. This is represented by capital letter K, and it is called equilibrium constant. Now we are arriving at the final equation. Capital K is equal to K1 by K2, which is equal to concentration of C raised to the power C, concentration of D raised to the power D, divided by concentration of A raised to the power A and concentration of B raised to the power B. The expression for equilibrium constant can be written as, this is the same equation. K is equal to concentration of C raised to the power C, concentration of D raised to the power D, and concentration of A raised to the power A, concentration of B raised to the power B. The general definition of equilibrium constant can be expressed as, the equilibrium constant K is the ratio of the product of active masses of the products to the reactants in equilibrium with active mass term raised to the power equal to the stoichiometric coefficient of the substance in the balanced equation.